So, one of the most useful inequalities which we will use over and over again in this course is called the triangle inequality. Let me start by explaining where this name comes from. So, if you have a triangle A, B, C, then what we know is that the length of the side AC is less than or equal to the sum of the lengths of the sides AB and the side BC, right. Why is this true? Well, if you believe that the shortest path between 2 points is a straight line, then this straight line joining A to C is certainly the shortest path from A to C. But here is another path from A to C, the path that goes in a straight line from A to B and then goes from B to C, and its length is the length of AB plus the length of BC. And so, the shortest path, which is the length of AC, has to be less than or equal to the sum of the lengths of AB and BC. Now, in vector notation you can write this in a slightly different form. So, let us call the vector that goes from A to B as the vector x. Let us call the vector that goes from B to C as the vector y, and then x plus y is the vector that goes from A to C. Now, if for a vector x I write absolute value of x as the length of the vector x, this is sometimes called the norm of the vector x, then the triangle inequality is saying that the absolute value of x plus y is less than or equal to, well, the norm of x plus the norm of y. Now, what we are going to use mostly in this course is a version of this inequality just for real numbers. So, the length of a real number is what is called the absolute value. So, it is defined as follows: for any real number x, absolute value of x is defined to be, well, it is defined to be x if x is greater than or equal to 0, and it is defined to be minus x if x is less than 0. So, now the triangle inequality says, I can state it as a theorem, triangle inequality for the real numbers says that given any real numbers x, y in R, the absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y. Now, I have justified this fact in the two dimensional case by drawing triangles and arguing about the shortest distance between 2 points is a straight line and so on. But remember, we said that whatever we do in mathematics should be derived from basic axioms, and so we need to prove this result, this inequality. We have here clearly a nice definition of absolute value, and we need to prove this just using the axioms for real numbers. And so, we can prove this by considering cases. The simplest case is perhaps, so case A, x is greater than or equal to 0 and y is greater than or equal to 0. So, in this case we know that if x is greater than or equal to 0 and y is greater than or equal to 0, then x plus y is also greater than or equal to 0. So, what we have is that the left hand side of this equation, let us call this inequality, let us call this T for triangle inequality. So, the left hand side of the triangle inequality is equal to x plus y, and the right hand side of the triangle inequality, well, what is absolute value of x? X is greater than or equal to 0. So, its absolute value is x. So, this is x plus, and then what is absolute value of y? Well, it is just y. So, the left hand side and the right hand side are equal. So, certainly the left hand side is less than or equal to the right hand side. Okay, let us consider the next case. What if x is greater than or equal to 0, but y is less than 0? Then what can we say? So, now in this case we will have two sub cases. First is if x is greater than or 0 and y, so x is non-negative, but y is negative. It is possible that x plus y, it could be both either positive or negative. So, if x plus y is greater than or equal to 0, then the left hand side of t is, well, it is just x plus y. And what is the right hand side of t? The right hand side of t is, well, x is greater than or equal to 0. So, the absolute value of x is x, y is less than or equal to 0. So, the absolute value of y is minus y. So, what we get is x minus y. Now, x plus y, if y is less than 0, then minus y is actually strictly greater than 0. So, x minus y is greater than 0. So, what we have is that the left hand side is strictly less than the right hand side in this case. Now, there are a few more cases. I will let you figure out what they are and work out the proof in a similar manner, but each step is quite simple, and you will, I am sure you will be able to do it yourself. An interesting variant of the triangle inequality is about the difference of absolute values for any real numbers x, y in R. The absolute value of x minus the absolute value of y is less than or equal to the absolute value of x minus y. The proof, well, it is very simple. The absolute value of x, well, I can write x in a fancy way as x is x minus y plus y, right. And now I can apply the triangle inequality to the first number as x minus y and the second number as y. So, this is less than or equal to, by the usual triangle inequality, absolute value of x minus y plus absolute value of y, and then bringing this absolute value of y over to the left hand side, you will get this version of the triangle inequality.